If you have like 6 hours a day that you're spending in school and college, if you spend that 6 hours a day learning a software, if it's mechanical engineering, you're doing AutoCAD and Inventor and SolidWorks, and you're constantly just watching YouTube videos on. Hi, how's it going? I'm Malachi, CEO and engineer of Elite Automation. Today is going to be a little bit hard of a video, a little bit of a tough topic. This video is going to be going over the gap of kids coming out of school, out of college, and the automation industry. And basically what I'm seeing a ton of is that kids coming out of college, and especially with an engineering degree, are just not having the skill sets needed or required to be able to perform actual tasks within a job. I do 110% agree with, on-the-job training, right? But if you're a mechanical engineer and you've used AutoCAD 3 times, how are you a mechanical engineer? I understand that you may understand a lot of physics and you may understand a lot of different metrics that go into mechanical engineering, but if you can't actually take those skills and be applicable with them, then what is the point of knowing anything? The whole entire purpose of going to college, in my opinion, is that you come out of college with the ability to be applicable to a job. It's to get you over that step of, I don't know anything, to now I at least know enough that somebody can kind of teach me the specifics of their business, and then I'm ready to go. And the reality of the situation is it's not occurring like that. And something that I think is an even bigger issue is you have these robotic, mechatronics, like industrial technology degrees that are better than an engineering degree. So you're spending half the amount of time. You're spending 2, maybe 3 years on a degree, and you're coming out of school almost double the skill set of somebody coming out of school with a mechanical engineering degree. Especially if you're going into a manufacturing or automation type of career path. Don't get me wrong, like there's definitely some engineering programs that are going to be more designed toward certain type of job skill sets. For example, one of those job skill sets may be like circuit board design. So there may be some really good schooling out there for circuit board design, but there's really not too much out there as far as like being directly related to automation, and the stuff that is directly related to automation is those applied sciences technology degrees. And I think there's going to be definitely a major shift in the whole schooling aspect of things, and engineering is going to have to almost shift a little bit and offer more controls engineering type of degrees, because whenever you refer to controls engineers in our industry, which is like PLC programmer, robot programmer, they're not necessarily or technically even an engineer. A lot of those controls engineers are these technical guys coming out of school that maybe went through maintenance for a while, or just got thrown to the wolves and started doing programming stuff, which is kind of crazy because it's one of the highest skill set things that goes on within like automation and system integration. And so it just kind of blows me away that we don't have better systems for that yet. That somebody hasn't predicted those type of things. Now, they have on the technical side of things, but they haven't on the engineering side of things. And I think mechanical engineering is probably going to be the most applicable in being able to like switch whatever you learned in school to be applicable to a job, because you probably are doing some stuff in some type of AutoCAD software, whether it be like Inventor or SolidWorks or regular Autodesk 2D. Now on the electrical engineering side of things, like almost all the people that I talk to, they're not walking out with the ability to build a control panel. And to me, that's a pretty low-hanging fruit, and I feel like you should be able to design a control panel, at least a simple control panel. And I think somebody walking out of school with an electrical engineering degree can learn how to do a controls panel fairly quickly. It's more so a lot of the common practice stuff that they're going to have to learn, like, hey, that's weird to put that device there. You shouldn't do that. You should always put, start off with your breakers here and then da-da-da-da. So what's the way to get around this if you're about to graduate with an engineering degree, or if you're trying to decide career path or what type of school you should go to, where you should go to school, what type of degree you should get? What I would suggest, if you're getting into the industrial automation space or the manufacturing space and you're wanting to be some type of engineer in the space, I would suggest highly that you go through some type of technical program that's in like an applied science and go through something that's going to be the most applicable towards an engineering degree. So your credits can transfer over to whatever engineering degree. So I don't know if that means you're going to a college. For example, we have like a USI here. I don't know if they have a robotics program. We have like Vincennes University. I think they have some pretty good partnerships with being able to go on to like the next program. But just check like the local schools in your area if you're just trying to go to a different area, whatever. But find classes that you can take or find a degree that you can take that transfers over to an engineering degree as well as possible. So your first degree would be something along the lines of like mechatronics or advanced automation or robotics or industrial technologies, basically stuff that's going to be dealing with like PLCs and robots and control panels, things along those lines. So get that degree, but it's highly important that you get things that transfer over to an engineering degree, because a lot of these technical type of degrees, applied sciences degrees, do not transfer over to a engineering degree hardly at all. You might have like 3 or 4 classes that transfer over versus like the entire like 2 years of schooling that you took, which means whenever you go to start your engineering degree, you're literally starting at ground zero. So now you're at 4 years. So now you spent 2 years getting this degree and 4 years getting this degree. Now you're 6 years into school. You pretty much could have got a doctorate. But even then, like, you probably are still better off going that route than trying to get a doctorate in engineering as far as being applicable. Now, I don't know on the side of like getting hired. Like, personally, I don't care if you have a doctorate degree in engineering. I don't even care if you have a degree in general. As long as you have all the skill sets necessary to come up with like a robust design and robust system. Something that you can do, and really this should be taught in like high school, is if you have like math classes in this first degree over here, you can take that math class and say, hey, I go to your advisor or whatever, say, I want to swap out this math class for the one that's an engineering math class. And a lot of times you can get an advisor to sign off on something like that, and that's a huge, powerful move. I was able to get my second degree in half the amount of time because I would go to my advisor and be like, hey, look, I want to take this class instead that applies to this next degree. So that math class that you're going to be taking for your engineering is definitely going to be a lot more difficult, and that class you're going to take that's going to go towards your engineering degree is definitely going to be more difficult than the applied science one. So that's one thing about the applied sciences type of degrees. The core classes are generally way easier than, like, say, for instance, an engineering level core classes. And that's because, you know, an engineer has to deal with a lot more paperwork. You know, you're going to have better writing skills because you're generally going to be writing up more reports and more professional reports that are going to be going to upper management. And your math, obviously, mechanical engineer, you're going to need to have some fairly decent math skills to be able to calculate stuff like torques and loads and things along those lines. And I'd like to just go ahead and throw in there real quick that going to a college that has that first degree, that applied sciences degree, industrial technologies degree, if you go to a class that has some type of pre-engineering type of degree, where it's like a 2-year pre-engineering type of degree that's meant to pass off onto the next thing, that'll actually align you a lot better, because then you're able to, you know, go into an advisor and do a lot of the footwork yourself, because a lot of these advisors, to be honest, they'll tell you can't do stuff, and you really can. So make sure you're kind of pushing your advisor into letting you do what it is that you want to do, depending on how good your advisor is. Don't get me wrong. I had some fairly decent ones, but sometimes you have to go in there and lay the paperwork in front of them and say, hey, I will take this class versus that class. So if you go in there with that pre-engineering type of degree, and you go in there with that industrial technologies degree, and you say, hey, I want to take this math class on this pre-engineering versus my math class, and also still make sure that pre-engineering math class does convert over to your engineering degree. But a lot of those pre-engineerings are completely designed to take a cheaper route to get the first half of your degree, to then go on to a more expensive college and get the bachelor part of your degree, or a master's if you want to go that route. Another thing, whenever you're doing this whole degree thing, make sure you are really utilizing your electives. Like, find out your electives. Like, it may only give you like 3 options. Like, there may be like psychology type classes, and like, you know, those other classes that are kind of just like the extra classes you may have to choose, like, I don't know, between like social behavior and psychology and whatever, right? Well, your mechanical engineering degree is going to require the same thing. So if you can, like, those classes, don't forget to do those. Like, to be honest, especially those electives that were free range and you could choose anything in this program, those are most likely going to be able to apply to an engineering degree than probably any other thing. And they're going to take the least amount of work because they're an elective, so it's kind of just a free range class anyway, to just kind of add more skill set and maybe to focus closer to the career outcome you're wanting. And that's another thing to keep in mind. Don't just take easy classes. Take classes that are going to be more applicable to the career that you want to take. And that's going to be a big difference because like if you have the option of doing like electrical design and a mechanical engineering class for an elective, I'm going to throw out a pretty bizarre example here, but let's just say for instance like there's like a panel building class. Let's say you're going for electrical engineering, right? There's this panel building class and you don't have to take it because like not all electrical engineering is going to be panel building, so it may be completely unapplicable to you. But if you have the option of taking that panel building class versus baking like cooking food, right? You're way better off taking your controls class. Now that's a pretty bizarre example and people will be like, duh, but there's people who go to college and they'll take that baking class and it's like, you're going to college to get to the next step in your life, to be ready for jobs and be able to be applicable. I've talked to many interns where they're like, yeah, I can't really find a job at all because like I pretty much don't have any skill sets, applicable skill sets. And on top of that, they're kind of wanting a higher salary because they've graduated with a engineering degree. So, you know, they're automatically thinking like, oh, here I'm at this bottom dollar for the degree that I have. But the reality of the situation is if you think this is your bottom dollar and your skill set's down here, either nobody's going to hire you or you're going to have to take a pay cut. There's one of the two. And like a lot of manufacturers these days, like a Toyota a lot of times is going to pay better than like trying to come like work for a systems integrator like myself with being a smaller company and whatnot. Like it's hard to compete with like Toyota's benefit packages and like, you know, they're starting like people like just line operators like $18 an hour. So you can easily get stuck in that, well, wow, I could go over to Toyota and start making like $18 an hour or whatever it may be. You know, maybe they guarantee like 21 an hour after like 6 months or something like that. For me, it's like, yeah, if you're applicable, you're well worth that. You know, you to me, it's like anybody who's applicable and can design stuff and we can just have like basic engineering conversation and you can design for me. You're in the 25 plus an hour range for me, what I consider. But if you're not able to really do anything on your own, then that you're almost at like $14 an hour. So there's like a huge wide range. Now, if you can spend 3 to 6 months of your own personal time or through schooling to learn AutoCAD and be able to have those skill sets to be applicable, you just immediately jump from like 14 to like 18, 21, 22. Now you're up in that range where like now we can start competing with like these other companies because we are hiring a higher skill set job. But for our industry and for what we do as systems integrators, with our business models, we have to have people who are applicable to a job. Unless you're like a massive systems integrator, you just don't have a ton of money just to hire engineers who really just can't do anything. And the reality of the situation is it honestly doesn't take much time to be able to start like maneuvering AutoCAD. Like you could probably put in 120 to like 500 hours into AutoCAD, which is what, like 4 weeks or something. And then you're probably up to speed enough to be in that like $18 to $22 an hour range. But that's going to be you just playing every day, all day, like, or just every evening, 4 hours a evening. But you could easily get there. You can get there in no time. You could have an 8-hour day, come home, put in like 4 to 8 more hours on AutoCAD after work. And if you do that, the thing is, if you do that for like 6-9 months, you're easily going to be in that range. Like probably not even that. You're probably 3 months you could be up to that speed. And that's really the thing is like that small window. I mean, even a month of doing that. If you put in 160 hours, that dedicated time towards doing that, that's going to boost your skill up. You're going to learn so many different things. And being that you're in a learning mode, it's not just a work mode. So like now you're trying to research things and find ways to do it better and faster. And so like there's a lot of, major skill. You're able to acquire a lot of skill over a short period of time. Whereas like, honestly, I've gained a lot of my skill from going into learning modes where I'm not even trying to do anything. Like, honestly, that's part of the reason why sometimes we'll do these product videos. Is because I'm going in, I'm just trying to learn the product. I'm going in and learning the product and just like, just playing around with it, poking buttons. And like, that's really the best way to learn. Because as soon as you have an application and you're trying to do the application and you have this new device, you're trying to get your application done. You're not really worried about trying to learn on this new device. So definitely spend some of your time on trying to build your skill set, learn on your own, get AutoCAD, pay for the monthly subscription or whatever it is. I think it may be like $60 a month or something like that for like an AutoCAD monthly subscription. So just go ahead and do that. Like start applying yourself towards the particular thing that you're going for and really target the industry that you want to target. So if you want to work for a manufacturer, go work for a manufacturer. If you want to work for a systems integrator, work for a systems integrator. Find out who you want to work for. A lot of times people don't have a clue. They just want a job when they get out of college. But if you know a path, like what you want to do for like the next 5 years out of college, if you can just at least set a path, even if it isn't the 100% path you want to go down, if you just set a path and then line everything up towards that path, For example, you take all your classes towards whatever that path is. So it's like panel design and da-da-da-da, like very targeted towards that as much as possible. Then on your free time, do as much like work in the softwares that are used within that specific job title or role or position. Then whenever you get out of college, at minimum, you'll now be applicable to an employer and will highly increase your ability to get a job. Like I said, somebody come to me and say, I have a mechanical engineering degree. They say, hey, I can't really do nothing in AutoCAD. I'm like, okay, cool. Like, I don't know what I can do. But then somebody can come to me and be like, dude, to be honest, I don't have a degree, but like, I'm kind of a beast at AutoCAD. I've been doing it since I was like 14 years old. I'm like, okay, dude, you're hired. That right there is such a huge value add. We're going to college to improve ourselves, to be able to get jobs and whatnot. So do the right things to actually get you there. To be honest, at this point in time, with as much stuff that's on like YouTube and everything, I can't advise against this because I don't want to ruin anybody's lives. But personally, I think you're way better off taking all the time that you'd spent in college and applied it towards literally just learning the software and learning things about the industry. Like literally, if you just clocked in, like if you have like 6 hours a day that you're spending in school and college, if you spent that 6 hours a day learning a software, if it's mechanical engineering, you're doing AutoCAD and Inventor and SolidWorks, and you're constantly watching YouTube videos on how to do design stuff and da-da-da-da. That's so much more applicable. Like, literally, honestly, somebody doing that for 6 months straight to a year straight, like, is going to be almost more valuable than somebody coming out with a 4-year engineering degree. It's crazy to think like that, but people say, oh, well, college shows dedication. If you spent 1 year of your time, free time, nobody telling you to clock in and learn that stuff, that's more dedication than going to school. Because there's still somebody telling you, hey, be here at 8 o'clock. There's nobody telling you to jump on your computer and self-teach yourself. To be honest, it's one of the biggest values that somebody can have, or biggest like traits that somebody can have, is to be able to self-educate themselves outside of school and to take those extra steps. Another thing I'd like to add before I forget is to work for a systems integrator, especially if you really want to go for the automation industry, and work for a small systems integrator where they're going to expose you to a lot of different stuff. Now, that'll help a lot with flavor testing, especially if you don't know exactly what route you're wanting to go. Like, say, for instance, you're like, oh, I might go mechanical engineering, I might go electrical engineering, but you're just kind of taking your general classes at first before you find out. Or if I want to program robots, or I want to program PLCs, like, if you have some general idea, you could work for a systems integrator, say, hey, do it as an internship or whatever, or if you can just get a job somehow, even if it's fastening bolts or something like that. Just being in that space of a systems integrator and seeing systems built and being exposed to the language and people talking about it, you're going to get more exposure to like any manufacturing equipment there than you will anywhere else, because like you're talking about it being designed, which means the conversation about it is much higher than, say, for instance, a manufacturing facility. They're going to be talking more about like production numbers and like keeping things running and preventative maintenance, and there's a whole different language between the two. Working for automation departments is another really good route. It's almost the same as working for a systems integrator. So some companies, some larger manufacturers, for example, like Berry Global, they have their own automation department. I've actually done some work with the Berry Global automation department before, and it's very similar to a systems integrator. It's almost identical. It's set apart like its own department. It's its own, essentially, company. It's not its own company, but it feels like its own company. A lot of times it has its own shop. Like, it's not even in the same building as the other one. So they're doing like new system design type of stuff. So that's another very good route. And especially if you think you're going to work for a manufacturer versus a systems integrator, that may be the best route, because like you can just you can get started within that company, and maybe you can make that company like a lifetime type of company. It's kind of harder for our generation. It's not doing it near as much, but if you're that type of person where you feel like you'll be somewhere long term like that, then that might be a really good route, because then you already got your foot in the door, and you can spend a couple years doing like mechanical assembly stuff, and you're still like getting yourself known within the company and able to climb the ladder and move up to where like 5 years from now you're the guy like running the show and doing project management, and who knows where you could be at. But working in those type of departments, and like I said, going with a smaller company, they're going to give you more flexibility, whereas like larger companies, they're going to have more set roles, like, oh, you're a mechanical engineer, you're stuck in that kind of that box. Whereas like smaller company, and I think this is good for overall beginning of your career anyway. The small company is going to allow you to taste a bunch of different stuff, and then you can really decide like, what do I want to do? And some of those smaller companies will allow you to completely move over to different job roles, job tasks. You might be a mechanical engineer for some period of time, and then you say, well, you know what, I actually want to try out electrical engineering. And depending on how low you're willing to be paid, a lot of them companies won't care at all. Like if I had somebody come to me and said, "Hey, pay me $14 an hour," and like, dude, I'm gonna sit here and learn mechanical engineering, electrical engineering, PLC programming. I'll learn it all, man. Just like I just want to be exposed to everything as much as possible. I would allow that person to jump around, but it's hard to let somebody jump around who wants to make like 20 an hour, because like that person now is a liability in the sense of payroll to the company. It's harder to not be putting out a completed product and be able to and operating as efficiently as possible, because a lot of times those dollar amounts we're paying for efficiency, whereas these two guys might be able to do the exact same thing, have the exact same skill set, but this guy's 20 an hour, this guy's 25 an hour, but it's because this guy can do it quite a bit faster, maybe even double the speed of the guy that's making the 20. Just keep that in mind. So like honestly, the lower you're willing to be paid, the more opportunities that are going to be offered to you, and that's a great method. Do internships, be willing to take a lower pay cut, so that way you can get your foot in the door and show them what you're capable of doing. If you really are a shark and you're able to execute on things, like people will pay you more. They won't want to lose you. They just be that person. So guys, hopefully this video is useful. If you have any other questions or comments, put them down in the description below. If you'd like for us to help you with system integration, contact card at the end of this video, and we'll catch you on the next one.